Alright, so 33 talks about static equilibrium, and it says, repeat the swing problem shown in example 5 if Stacy pulls Danny through an angle of 45 degrees. So already I'm going to write angle 45 degrees equals 45 degrees. And then holds him at static equilibrium. Find the magnitudes of both h and t. So I'm going to go back to example 5. And they give me a picture that I'm going to draw. So you guys know the kind of drawing I have. Here's the swing. Here's the kid here. He looks like he's hanging, but we'll pretend like he's sitting on a swing. It is terrible. I'm not going to lie. It's terrible. I'm a terrible drawer. Alright. And then here's the person that's pushing the kid. Terrible, I know. It's terrible. Alright. So, Danny is 5 years old and weighs 42 pounds. Okay? So, we need to know how much he weighs because that's gonna be part of what we're gonna use to solve the problem. He is sitting on a swing when his sister Stacy pulls him in the swing back horizontally through an angle of, and they wanted us to change this angle. So this angle is now 45 degrees. So she pulls him back and she's gonna let him go. Find, and then stop. Find the tension. Okay, so she's not going to let him go yet. She stops. Find the tension in the ropes of the swing and the magnitude of the force exerted by Stacy. Okay? So, and they give you a little drawing here, which makes it a little easier on yourself. So, they do it, this thing here is T for tension. And tension can be broken up into weight, which is going down because it's gravity, and a value h, which is talking about the horizontal, like, pull. Okay? So, W is 42 pounds, and it's straight down, because that's the weight of the kid. 0, 42. Does that make sense to you guys? Yes? No? Okay. So, the H represents the force which she is pulling him horizontally, and T is the tension. Okay? So, if we rearrange them, so we want to put them together, it's best, we can put them in a triangle. So, what we're going to have is the horizontal, so we'll have the vertical, the horizontal, and then should say the vertical is working like this. The vertical is going down to the horizontal is pulling this way, and the tension goes from here to here. So this is vertical, horizontal, and this is tension. Are we okay with that? Now the angle, yes, it's down, right here it's down. So from here to here is 45 degrees. And right now he's in static equilibrium because he's not moving. So all of the forces, these are all of the forces acting on him, they're all going to add up to 0. Does that make sense to you guys? Yes? So we could say W plus H plus T equals 0. Well, equals the 0 vector, which is 0, 0. So, we know that we're going to use only magnitudes of the vectors. We know that if we use cosine and tension, like we already, what is W? We already know that W, 42, yeah. So we can fill in W for ourselves here. Okay, and remember we want to find the tension, and so we want to find H and T. So if we know W is 42, which one do you want to find first? It doesn't matter. H. So H stands for Stacy because she's the horizontal pole, okay? So what trig function is going to be use 45, 42, and H? What trig function relates? Sine would be opposite tangent, okay? So we'd say tangent 45 equals opposite, which is what? Opposite of 45. What side is opposite? H, right? Over what's adjacent? 42. We can fill in 42 because we know the answer. So how do we solve then? Good. Multiply by 42, those cancel. So we have H, or Stacy's magnitude. We should say this is magnitude. Stacy's magnitude is 42 tan 45, which is just 42. Okay? Now we want to find out T, okay? So how do we relate T, W, or T, 42, and 45? Here's T, here's 42. This is the angle. It's not tangent, right? Because that was these two. So we have two other choices, sine or cosine, right? Sine would be opposite. So is H is opposite, so then W is adjacent. So adjacent over hypotenuse would be what? Cosine. So we're going to say cosine 45 equals the adjacent side, which was 42, the magnitude of the adjacent side over the magnitude of T. When we have it like this, we cross multiply and divide. So how do we solve? I cross multiplied these two and these two. How do I solve now? Divide by cosine 45. So I have the magnitude of T is 42 divided by cosine 45, which is 59.40. And these are measured in pounds. So this is Stacy, and this is the tension.